section 1, which is called tangent lines and the derivative at a point. So since we've been started, what has been the recurring theme that was stuff we've been looking for? When we did the difference quotient, what was it looking for? When we did the limit, what was it looking for? The difference quotient, let's review that. Was f of x plus h minus f of x over h. That look familiar? What does it look like? Remember, what did h represent? How did we define h a long time ago? H was the distance between x1 and x2. If we had a curve, we found a point there and a point there, and we could find the slope between them. So h is actually, because the distance between two numbers is, how do you figure that out? So if I had 2 and 15, how far are they apart? Not 2 minus 15. It'd be the second number minus the first number. So h is x2 minus x1. So this number here, this f of x2 is actually f of x plus h. Because I start here, I add h, I go to this one. So this one is the same as f of x2. So that's the same thing as, which is what? Yeah. It's the slope. Because we started off talking about the difference quotient and we're looking at finding the slope between 2 points. Now what we're trying to do, as h, this is when we talk about the limits, as h got smaller, what we're looking for, because this formula only works if you have 2 distinct points, doesn't work to find the slope of a curve. So what we're doing here is we're making h smaller, so we're changing the slopes. Eventually, we'll get to the slope of this one line here. And if you zoom into it, this is at x1, we're looking for that line. What do you call a line that touches a curve at one point? Tangent. This is the tangent line. Because we only have 1 point. What do we call a line that has 2 points through it? Secant, right. But the secant line doesn't work when we look at curves because it doesn't tell us the true shape, the slope of it. The slope is also rate of change. What we're trying to do, we're trying to get x2 closer, 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 and eventually becomes x1, so we have a tangent. So we're looking for, we want the slope of the line tangent to the curve at one point. Because then at that point, we know what the slope of that curve is, the rate of change of that curve at that point is. So let's look at the definition. The slope of the curve y equals f of x, it could be any curve. It has to be continuous as well. Because remember, why does it have to be continuous? Because we looked at finding the limits, and the limits always have to point to the same value. There can't be disconnections. So it's got to be continuous. Slope of the curve at f of x at a point, let's call that point x sub 0, f of x sub 0 is given by the value given by the equation so the slope is the limit as h goes to 0 of our difference quotient. So that's our slope. Simply because, unlike linear equations, do curves have the same slope at every point? No. Sometimes, if you think of a parabola, at this side, what are the slopes? Are they positive or negative? They're negative because they're pointing down. At this side, they're positive. Between there has to be a point where it's 0. And that point is the vertex. I would talk about the highest, the maximum, minima, the extrema points we talked about. Let's do an example. Do example 1. A. Find the slope of the curve y equals 1 over x at any point x equals a cannot equal 0. Why can a not equal 0? Yeah, because if 0 on the bottom, it's undefined. What does that slope look like if it's undefined? What does an asymptote look like? We have 2 types, 3 types actually. We have a horizontal, vertical, and oblique. Right. Because a vertical line, by definition of the vertical line test, if you have multiple points on the same x value, the slope is undefined. And so that's if you have an undefined function, that means the slope is undefined because you have multiple points going straight up and down. And we'll talk about this in calculus too, about finding the surface area of vertical slopes. Where was I? Find the slope of the curve y equals at any point P as x equals a. What is the slope at the point -1, -1? That's the first one. Where is the slope equal -1/4? And C, what happens to the tangent line to the curve at the point A, 1/A, as A changes? All right, so let's look at the first one. Find the slope of the curve y equals 1/x at any point x equals A. How do we do that? Have we defined the slope anywhere on this page? The limit. So here are my solutions. A. So the function is 1/x. What else do I need to find? So I have to use this formula. Limit as h approaches 0 of the difference quotient. So what else do I need to find before I can just plug it in there? Nope. Nope, because we don't have the rest. We have to set up the entire equation first. Do we have everything we need? What are we missing? We have the function. X could be any value. Look at this. What are we missing? Okay, let's narrow it down. We're trying to find M, so we don't have that. H goes to 0, so that defines. So we don't have to worry about H. We have f of x. What's the only thing we don't have? We don't have f of x plus h. We can't even do this because we need to have everything defined. So what is f of x plus h? Very good. Anywhere I see an h, I put an x plus h. Okay, now I have everything I need, so I just plug it in there. The limit as h approaches 0 of 1/x plus h minus 1/x over h. Remember, whatever's after this minus, this f of x part, always put in parentheses. Now we have to work it out algebraically. So we have the limit As h approaches 0, what do we got to do first? How do you solve this thing algebraically? Because to be honest, that's the calculus part. The rest of it is algebra. How do you solve it? Nope. Can you do the subtraction? What do you have to do to subtract fractions? You have to have a common denominator. So you have 1 over x plus h here, and you have 1 over x here. This side has an x plus h. Does this side have an x plus h? No. So it needs an x plus h over x plus h. This one has an x. Does this one? No, it has an x plus h. So it needs an x over x. You have to simplify the equations first before you combine the top and bottom. So we have x over x plus h times x minus x plus h over x plus h times x. So we have a common denominator on top, so it's x plus h. We have an x minus x plus h. Yes. Not yet, because we have this minus to worry about. Because if you just drop the parentheses, then the only thing changes is the x. This one, we have to distribute. Both sides have to change. So the denominator is x plus h. So the top now becomes x minus h, because this negative changes both of those signs. The x's cancel. And on top, we only have negative h. So we have a fraction over a fraction. Bottom is x h over 1. So we take the top fraction, leave it alone. And flip the bottom fraction and multiply it. The rule of multiplying fractions is reduce first. Can anything cancel? What? The h's. So this h goes in h once. So on top, we only have -1. On the bottom, we have x plus h. Can we do anything else algebraically? No, it's as far as you can go. So now what we do, we take h to 0. Anywhere you see an h, it goes to 0. That takes care of the limit part. So we have left x times x, which is -1 over x squared. And that's our slope formula. That's the slope of the curve at that point. Or any point, I should say. Because what A was looking for, it was find the slope of the curve at any point x of A. So if I put A in there, we get -1 over A squared. The question is asking, what is the slope at -1, -1? So our slope equation was -1 over x squared. What is the slope at -1, -1? So to find that, what do we need? Do we have an x value? Yeah, because remember, this is a point, so it's x and y. The x value is -1. -1 squared. What is -1 over -1 squared? What is -1 squared? So -1 over 1 is -1. Be very careful whenever you do this kind of work. Whenever you plug in a number inside there for x, make sure you put it in parentheses. Because if I had what is this one going to equal? What's it going to be? What's this going to equal? Right. Because this 2 order of operations, this is multiplication. This is -1 times 2. 2 to the power 2. Which is more important in exponent in order of operations? Exponents or multiplication? Exponents. So we have to do 2 squared, which is 4, and the negative stays out in front. This one, I do the whole parenthesis, -2 times -2. So be very careful about that. Okay, so what's B looking for? B is saying, where does the slope equal? Slope equals -1/4 when x equals what? Remember, our equation was the slope equaled -1 over x squared. When the slope equals -1/4, since both top numbers are both -1, we have to make sure the bottom numbers are equal. So when does x squared equal 4? Remember, the exponent tells you our number of solutions. We have to have 2 solutions. So if I had x squared equals 4, how do I get rid of the square? Square root it. So the square and the square root cancel. Square root of 4 is 2, but that's only half right. Whenever you square root a squared term, that value can be positive or negative. Because -2 squared equals 4 and +2 squared equals 4. So our function is true whenever x equals 2 or -2. So what are the locations of those 2 points? Because this is not correct. This is just the location of it, the x value. Is that where the slope is -1/4? No. What this is looking for is it's at positive -2. Where is it? Where is that? What are those points? We're looking for points here. Because the question says, where does the slope equal -1/4? Where on the graph? -2 and +2 is not on the graph. So how do we find the locations? You have the x values. What do you need? You need the y values. Where do we find the y values? Where? To where? What's the function? Yeah, because we were given in the first part y equals 1 over x. We have to find x, y. These are the locations where the slope is -1/4. So we have one of them at 2, and we have one of them at -2. You're right. Plug them into the function. So it's at 1/2, and this one's at -1/2. That's the location. That is where the function slope is equal to -1/4. Let's see, what's the next one asking for? What happens to the tangent line to the curve at the point a 1 over a as a changes? What happens to the curve as a changes? Yes and no. C is what happens to the tangent line at a 1 over a as a changes. It helps to know what the graph of the function looks like, which is why I asked you guys to memorize the library of functions. What does this graph look like? The graph looks like this. So what happens to the tangent line? In other words, what's the slope of the curve as A changes? It's going from negative infinity to 0. It's almost horizontal, and it gets to be almost vertical. That's what happens here. Then from 0 to infinity, it starts off almost vertical, and then it becomes horizontal. But it's always a negative slope. It's always a negative slope. Because this is an odd function, so it's decreasing constantly. All right, let's look at the next one. Well, let's move on to the same. Any questions about that? So we're getting closer and closer and closer to defining what we're actually looking for in calculus. So rate of change with rate of change, what's another name for it? Yep. We call those the derivative at a point. Because now we're going to define what we're looking for. This is what the whole thing we're looking for. So we have it right here. The rate of change is equal to what's called the derivative. So the slope equals the derivative. The derivative, we define it, it looks like this. We have our function, looks like this. This is one of the many ways we could represent it. It's called f prime of x. That's how you would read it. F prime of x. That equals the slope. But what's another way of writing the slope? Yeah, but we haven't talked about it. That's for trigonometry. This is calculus. So the slope, we just talked about it. How do we find the slope in the last question? What formula we use? The limit of the difference quotient. So there we have our definition. There we have our formula for it. Again, now it just means more than slope and rate of change. There are other applications to it. For example, in motion problems, the rate of change, you have a position function. That's where an object is at one point of time. As it's moving, what happens? Well, as it's moving, it has T1, T2, which now correspond to S of T1 and S of T2. So the change of position is called the velocity. Equals the change of our position, which is the first derivative of our position. So the velocity is the first derivative of our position function. Well, then what's acceleration? Acceleration over time is velocity 1 and velocity 2. It's the change of velocity. So the acceleration of a function of a particle means it's the first derivative of the velocity, or we could look at that, it's the derivative of the derivative, which is the second derivative of the position function. So you can have rates of change, slopes of slopes. So that's what we're looking at here. Let's look at example 2. In examples 1 and 2 of section 2.1, we study the speed of a free falling rock from rest. Okay, you have a free falling rock from rest. This is important, but it tells us its initial velocity. The rock fell we're looking for its position at 16 t squared feet. During the first t seconds. And used a sequence of average rates over increasingly short intervals to estimate the rock's speed at the instant t equals 1. What was the rock's exact speed at this time? So what are we looking for here? What are we given? What do we need? What do we have? What are we looking for? What's that? Let's draw a picture of what we have here. So a rock was over here. It was how far from the ground? We don't know, but it fell off. 16 t squared. What does 16 represent? Because it said a free falling rock from rest. That means nothing pushed it. So it just started off at 0. So at the very top here, at t equals 0, its velocity or speed was 0. Then when it started falling from rest, the only force acting upon it is gravity. Gravity is 9.8 meters per second squared, or 16 feet per second squared. It's called the MKS versus the what's that? The United States measuring system. I'll think about it later. But this is metric. This is the US. So whenever it all depends. We know it's the US because they're using feet as opposed to meters. All right, so we have to make that distinction first. So then what else we're looking for? Free falling rock times t seconds, use a sequence of average rates. What does that mean? For the first second, we used a sequence of average rates over increasingly short intervals to estimate the rock speed. What does that mean? What do you think it means? A sequence of average rate. What's an average rate? Yeah, because we're looking at T1, it's here. At T2, it's here. At T3 is here. T4 is there. From T0 to T1, we know we can look at the velocity over the time. That's the slope formula. So we're looking at the rate of change over each of these. We can look at from 1 to 3, from the original to 3 seconds. How far did it go? How fast did it go? We can look at it from any interval we want to. So that's what it's saying. We look at using a sequence of average rates. Average rate is that. So what do we do with it? What do we do with it? So now what do we do with these things? Do we have a formula for it? What's the formula? Well, we have the formula, but the formula is f of x plus h minus f of x over h. And we're going to look at the limit if we want to, because that will be telling us slope. But we're looking at the average rate. How far is it falling over so much time? So now we have to figure out what these mean. What do they mean? What is f of h? F of x plus h. How do we write that? What is our f of x? 16t squared. That's the y equals. So to do this, we have to find the first part. We have to find the x plus h part. How do we find that? The first one was at rest. Well, not really x. Since whenever you deal with motion, moving, your x-axis of your graphs is always time. So with this one, we would have time plus h minus f of time over h, because we have a moving object. So what was our time we're looking at? Look at your question. What was our time we're looking at? So our time is 1 plus h minus f of 1 over h. How do we relate this to, how do we relate this back to our function? What is our function? 16t squared. So it's 16 1 plus h squared minus 16 1 squared over h. Because anywhere we see a t, we put a 1. And the function is 16t squared. How do we solve this? What do we have to do first? Well, we have to first do this one. 1 plus h squared is equal to 1 plus h times 1 plus h. So what does that one become? One times one is one. One times h is h. H squared, which is 1 plus 2h plus h squared. One plus 2h plus h squared minus 16 times 1 plus 1 squared is 1. I could distribute the 16 now. So the 16s cancel. 32h plus 16h squared. Can anything factor out of the top? And what else? So it gives us 2 plus h. So our function becomes 16, 2 plus h. So that's our formula. What do we do with the h? What happens to the h? It goes to where? Yeah, the limit as h goes to 0, that goes to 0. So we have 16 times 2, which is 32 feet per second. That's the speed of it as it falls down after 1 second. So looking at your sheet I gave you the summary also on how to do these. If you can, always graph your picture first of the function. It'll help you determine whether your answers are right or wrong. Because if our graph looks like this, and we're looking for that point, and you come up with a slope of 1/4, what can you tell me about that? Is it right or wrong? Right, because this slope here is negative. So you know that your slope has to be negative. So either you forgot to put the sign up there or something along the way. So drawing the picture always helps to see what your answer is supposed to be. All right. Any questions about that? That's 3.1. Let's look at 3.2. Let me go here.